Alrighty, so today we're going to look at the remainder theorem and the factor theorem, starting with the remainder theorem, which is going on page 53. So we have a little warm-up here, but we're going to go through it together because you're capable of this, and I want to work you through something on here anyway. So it says, consider this polynomial function, and we're going to divide that by x plus 4. Is that something we're capable of doing? Yes. Would you choose long division or synthetic division here? I would choose synthetic division. All right, so -4, and that's going to divide into 1, 1, -4, 41, like so. Okay. So then I bring down my 1, -4, -3, 12, 8, 2, number like now I'm guessing myself. All right, and then what do I get here? 7 or 8 or 9. Yes, we'll just pick one. It's 9. All right, so now that I have that, once I've divided it in there, my answer then is x squared minus 3x plus 8, and then I would add my remainder, which would be 9 over x plus 4. Okay. Everybody good? We're rock stars at this now, yes? Okay, no biggie. All right, so the B part says find f of -4. So f of -4, I'm going to substitute this in here. I'm going to get -4 cubed plus -4 squared minus 4 times -4 plus 41. What's -4 cubed? -64. So it's -64 plus, this would be 16 plus 16 plus 41. All right, so 16 plus 16 is what? 32. 32 -64 gives me what? -32. So I really have -32 and 41. So this is f -4. 9. Okay. Did you know you were going to get 9 before you started? Yes, no, maybe. But this is what this whole remainder theorem is about. If I divide that -4 into here, my remainder is 9, which means f of -4 is going to give me 9 every single time. Okay? Does that make sense? So it's a little bit of an easier way, depending on your numbers maybe, to actually evaluate some of your functions. Okay? We good with that? Now, on number 2, we're going to do B first, because I want to see something that happens. So for B, I want to find f of 9. That's going to give me 7 times 9 to the 4th minus 63 times 9 cubed plus 9 times 9 minus 80. So I had originally planned on us getting this far, and I was going to give you a couple minutes to work it out, and then we were going to talk about it because I know exactly what most of you would do. You would jump in and start multiplying a bunch of stuff, right? And you'd have scratch work all over the place, and it's all a complete and total waste of your time. Are you capable of finding 9 to the 4th power? With that, you're capable of it, right? We're all capable of that. But I want to show you how, when we say work smarter, not harder, these are the types of things that you need to employ when you have things like this, because nobody's really expecting you to multiply crazy numbers like that. What you can do, though, or I'm going to work backwards so you can kind of see how this works. I'm just going to write from the right to the left this time. So I'm going to rewrite my -80 or minus 80. Now 9 times 9, no big deal, so that's plus 81. So as I go through, 9 cubed, you may know what it is, you may not, but let's just say that, even if we do, who cares? I've got I'm multiplying all these 9s here. This is 81. Well, I know if I take 2 of these, I get 81, right? And then I have another one, because there was 3 of them, right? Then I'm going to write this other one right here, and then this is minus 63, right? So that I just changed this to this, right with me? So now I have 9 to the 4th, which is 4 of them. Well, I can again take 2 of them and get 81, and then I have this 9 sitting here, so I can put a third one here. The 4th 9 that I'm supposed to multiply, I can multiply it by 7. What's 9 times 7? 63. Okay, so it's the same thing. I just kind of split my numbers up, understanding how the numbers work together, right? So at this point, what happens with these two terms? They cancel out. Now, I started with the 81s because I had an 81 here, which in the end doesn't really affect what's going on there, but that's okay. It at least gave me kind of a starting point. I don't have to the only thing I multiplied was 9 times 9. That's it. These two things zero out. I don't care what they are. And so I end up with just 81 minus 80. So what's f of 9? 1. Now, could I split this up differently? Yes, and it all depends on you're looking at like what's going through your brain. This is not the way I originally did it. I originally did it. Excuse me. I did this, but then here I know what 9 cubed is. So what is 9 cubed? Anybody know? 729. So 9 cubed, I've got that. It's 729. So I had negative 63 times 729. And then I used the 9 cubed here, so I had 729 times 63 here. And it works that way too. And then somebody asked me last period, well, if I split this up into like, 81, and then this is 9, and I left it as like 9 times 9 times 7, could I split this into 9 times 7 here? The answer is yes. I mean, you can put them together and take them apart as long as it's legal and you're not making anything up, so that things match, that you can knock things out pretty easily. And this saves you a lot of time, right? And although we're all capable of multiplying these numbers, how many of you would have potentially had the ability to make a mistake somewhere along the way? Yes, right here. I mean, myself too, because again, we can do it, but it doesn't mean we don't just do weird things sometimes. But it eliminated all of that for us. We didn't have to waste the time, the scratch work, the thinking, nothing. Okay? This is the kind of thinking that helps you on the SAT and the PSAT also. When they give you some weird, obscure stuff sometimes, they don't expect you to jump in and spend 30 minutes on the problem, because they might have only given you 30 minutes for the whole section. But it's how do you reason through what's put together? How do you put it together and take it apart? That sort of thing. Okay? That's your critical thinking and reasoning skills right there. Okay? We good? Any questions? All right, so now let's do this over here. We're going to actually divide, which means I have a 9 that goes on the outside, and then I end up with 7, and then negative 63, and then what? 0, and then 9, and then negative 80. Do not forget your placeholders. So then as I work through this, bring down my 7. So 9 times 7 is 63. Zero's out. So 0, 0, 0, 9, 81. And your remainder is 1, which now that we did the B part, should be no big shock. In this particular problem, if you forgot your placeholder here, you would get lucky because there's all these zeros here. You actually end up with the same answer in the end, sort of, except that you don't have enough spaces down here to get all your little coefficients. But either way, you might have lucked into the right answer, but it would have been luck. So in the end, I have 7x cubed plus 9, what? Is there a variable here? No, because that's my constant. Then plus 1 over x minus 9. Now, if I had, well, regardless of whether or not I actually multiplied these numbers out, if I had to calculate f of 9, which of these two processes do you think is easier? First or the second? The left one. I would say synthetic division probably, because if you don't always see this or it doesn't always work out that way, synthetic division was a little bit easier. Even up here, I mean, it's not like these numbers are hard, but that probably went a little faster for you. And f of negative 4 is 9, and f of 9 for this one is 1. It's your remainder right there. Make sure when you're writing answers, most of you are doing a very good job of this, but not everybody, that it's not just 9. F of negative 4 equals 9. You have to label your answers. Right? So this process, even though we're doing synthetic division, what it's called, oh, we'll get to that in a minute. I'm jumping ahead of myself. What the remainder theorem says is that if a polynomial function f of x is divided by x minus c, then the remainder is f of c. And c could be a negative number. If that was, x plus 3, then c is a negative 3, that sort of thing. So using synthetic division to evaluate that is what's called synthetic substitution. It's the exact same process. The difference is when I tell you to, divide this polynomial by x plus 3, you're actually doing synthetic division or long division and dividing them out. If I want to find f of negative 3, like we're going to do here, you still do synthetic division, but because you're doing it for a different purpose, it's called synthetic substitution. But the process is the same, so don't get that all mixed up. If you can do synthetic division, you can do this, no big deal. So this says, use the remainder theorem, which is synthetic substitution, to evaluate f of x at c. So they give us c here. Now, we're not dividing by a binomial. When you do that, you have to change the sign because it's x minus c. If they give you c, it is what it is. So since I want f of negative 3 is what gets divided in here. Because basically that is the solution. And then I would have a 1 and an 8 and a 12 and a negative 7 and negative 14. Right, sure with it, all right. All right, so I bring down my 1, gives me negative 3, 5, negative 15, negative 3, positive 9, positive 2, negative 5. I did something wrong. Oh, because it's not negative 5, that's why. 2 times 3 is not 5. In fact, it is what? 6. So negative 6, which gives me negative 20. So what that tells me is that it doesn't divide out evenly, right? But it tells me that since I use this negative 3, f of negative 3 is equal to negative 20. Okay. Everybody agree with that? Easy enough? If you can do synthetic division, you can do this. You're just using it for a different purpose. All right, so flip it over on the back, because we're not going to do every single example because we don't need to. I want you to do the first number 6. There's 2 number 6s. Just to keep you on your toes, we're going to do the first number 6. You agree with that? Yes? You needed that placeholder. Again, I think you get lucky if you don't put it there on this particular one, but you don't get lucky every time. And at this point, our actual answer to this would be, 2x cubed plus 2, but we don't care about that. We're using this for a different purpose, so that actually means nothing to us. We're just doing this to get the remainder. All right, let's do number 8. Everybody with me so far? Don't forget your placeholder, because it does matter on this one. So when I get here, 4 times 33 was 4 times 33? 132. Good. So it's negative 132. So my remainder is going to be negative. So I'm going to subtract these. I could subtract 10 and add 2 back. So that's going to give me negative 124. Any questions at all? We're all good because we're really good at synthetic division. If you're good at synthetic division, guess what? You're good at synthetic substitution because the process is exactly the same. Okay. All right, let's look at number 9, some application problems. It says, the number of tickets sold during the Oakdale High School football season can be modeled by this equation, where X is the number of games played. Use the remainder theorem to find the number of tickets sold during the 7th game of the season. All right, so they're telling me to use the remainder theorem, which means I'm using some synthetic substitution here. So what number do I use to divide by? 7. X equals 7. Now, if we didn't know the remainder theorem, I could take 7 and substitute it in, right? Do you want to do that by hand without a calculator? Because I don't, because those numbers are big. Okay, but that's why we like synthetic substitution here. So 7 divides into 1, negative 14, 45, 68. Okay. So bring this down. 1, 7, 9. Okay, so I got a remainder of 40. Is that what you got? What does that represent? Tickets, okay? So let's talk about reasonableness of an answer. It says the remainder theorem to find the number of tickets sold during the 7th game. So this is during the 7th game of the season. Does 40 seem like kind of a low number? Yeah, so it might. It doesn't mean that, I mean, we need to think about reasonableness of an answer. If it was like, 40,000, then maybe we'd be a little worried, or if it was 4. But even 40 is kind of low. So it's either a really small school or it's a really bad team or both, maybe. I don't know. But if the reasonableness makes you question things, just go back and double check your work, because let's just go with it's a small school. Maybe they're really, really good. All right, but I can't just put f of 7 equals 40, right? Because nobody asked me for f of 7. And I can't just say 40 tickets either. We need to actually say, what's happening here. So we can say 40 tickets were sold. And I can't stop there either because sold when, right? Sold during the 7th game of the season. And then if you really think about the wording, if 40 tickets were sold during the game, then that doesn't include the things that were sold before the game or the ones that season tickets, things like that. I don't know if that's the intention of it, but the way it's worded, that during the game is, you came late and you bought a ticket to get in. So maybe it's actually a really big school. And there's a lot of late people, who knows. All right, so then let's look at number 10. So 10 says the distance in feet that a person travels on a snowboard is modeled by this equation, where t is the time in seconds. Use the remainder theorem to find the distance traveled after 1 minute. Okay, so in here, coming from this, my first number up here would be 0.6, then 10. Is that it? No, it's not it. What else do I need? 0. I need a placeholder even when it's at the end because there's no constant term here, right? Then what's going to go on the outside? 60? Why 60? Because it's 1 minute, okay? Because it says remainder theorem to find distance traveled after 1 minute, okay? But t is the time in seconds, so I can't use 1. Last period somebody told me 4, but then he wouldn't tell me what he was thinking to get 4. I still don't know where 4 came from, but he stopped himself real quick, but still it seemed like a random thing to blurt out. But t equals 60. We're all good with y, right? Okay. So this is 60. Now, I have a decimal. Does that mean I need to freak out? No. When you multiply by a decimal, you just multiply, and then you move your decimal place over. So what's 6 times 60? 360. And how many times do you move the decimal place over? Once. So this is 36. Which makes this 46, right? So then what's 60 times 40? 2400. Good. And then 60 times 6 is 360. We just did that, right? 360. So if you need to jot that stuff down, the bigger the numbers are, the more likely I'm going to jot them down so I don't get numbers lost in my head. But then that makes this 2760, which makes this 2760. So what does the 2760 represent? The distance in feet. Good. So a person travels, right, okay, wait, a person, wait, it says, find the distance traveled after 1 minute. A person will have traveled 2,760 feet on a snowboard in 1 minute. And that is not a very well-worded sentence, but it's fine. I should have said a person on a snowboard will have traveled, but it means the same thing. Just don't tell your English teacher because it's not the best wording. But we got all the pieces in there. That's all we really care about. All right, we all good with that? Any questions? All right, grab the second piece of paper. And then you're going to have to remind me what page it goes on. 54, thank you. So we talked about the remainder theorem. So now we're going to talk about the factor theorem. So the factor theorem says, given a polynomial f of x minus c is a factor if and only if f of c equals 0. And that if and only if wording there is important because that tells you that x minus c is a factor if f of c equals 0, and if f of c equals 0, then x minus c is a factor. That's why we talk about converses and contrapositives and conditional statements and all that stuff in geometry, because once you get into theorems where you're going to have to be able to read through them more and make sure you understand them and which direction they work, that the understanding of that process is going to be important to you. Bless you. All right, so this says use the factor theorem to determine which binomials are factors of the given function. So this is a little bit different than what we've been doing. What we've been doing, they're saying, hey, this is a factor, divide it in there, or this isn't a factor, divide it in there and find the remainder. But we're trying to determine if these things are factors of this polynomial or not. So we're going to start by, and we still use synthetic division, right? I'm going to start by testing this one. So that means I'm going to test -1 being divided into this, which would be 1 and then what? 0, then -31 and 30. So bring down my 1. This is -1, -1, +1, -30, -30, 16. All right, so does this work? No, my remainder is not 0, which means that x plus 1 is not a factor. So for x plus 1, the answer is no. So then I try this next one, x minus 5. So I'm going to take 5, divide it into the same thing, 1, 0, -31, and 30. So bring down my 1. This is 5, 5, 25, -6, -30, 0. So for x minus 5, is it yes or no? Yes. Okay, so it is yes, and we're going to mark that. Now when we go to test the next one, we're going to do a little bit different, okay? Because I don't need to divide it into the same thing. Since x minus 5 is a factor and my remainder is 0, this is my remaining polynomial, right? If I wanted to write it out right now, I could say x minus 5 times x squared plus 5x minus 6. We're not going to have to write it out, but if we did, that's what it would look like. So when I test this -6, I'm not dividing it into this same thing. I'm using what I got right here, 1, 5, and -6, because I've reduced it some. And so it should work in the reduced form too. Bring down my 1, and I get -6. This is going to be -1, 6, and 0. So for x plus 5 or x plus 6, does that work? Yes. So here are 2 of the factors. And if you notice what you have left, this tells me this is x minus 1, right? So the fully factored form of that up there then is x minus 5 times x plus 6 times x minus 1. And I didn't actually factor anything. Does that make sense to you? We good? That's why we get to use the reduced form of that. Which makes it nice because sometimes the numbers can get big and the more and more you can reduce it, the better off you are. All right, let's try another one. So I'm going to test that x minus 2 first. So 2, I'm going to divide into 1, -6, -17, 78, negative 56, and then what? 0. You got to have something for that constant term as well. Otherwise, your remainder isn't in the right place. Bring down my 2. I'm sorry, I bring down my 1, not my 2. Bring down my 1. That makes that 2. Negative 4, negative 8, negative 25, 50, 28, 56, 0, 0, 0. So for x minus 2, is it yes or no? Yes. Okay, so that's good. I got a yes, which means I can reduce what I divide the next one into. I'm going to try that x plus 7. So minus 7. I'm going to divide that into my answer here. So 1, negative 4, negative 25, 28, and 0. So I bring down my 1. Negative 7, negative 11, 77. What's 77 and negative 25? 52. Okay, so I got to do 52 times 7. Or negative 7, it'll be negative. What's 7 times 52? Okay, yeah, so 7 times 5 is 350, and then 7 times 2 is 14, so that gives me 364. So these two, when I combine them, it's going to be negative, so I can subtract and just keep the negative sign. So here I can subtract 30 and add 2 back, so this would give me 334 plus 2 would be 336. Then I got to multiply these. When they multiply, it'll be positive. What's 7 times 300? 2100, right? That's easy. 7 times 30 is 210, and then 7 times 6 is 42, okay? So, and for me, I would at least write that down, or again, I'm going to get those numbers lost in my head. I combine all that, what do you get? 2352. Now, depending on the purposes, now at this point, I want to see all of this stuff. But if you were just testing it on your own because you're running through some things or whatever, did you know before you actually got this number that this wasn't going to work? Yes, okay. I'm going to make you do it anyway, but I just wanted to know if you knew that. So x plus 7, because you need practice multiplying, is a no. So when I go to test the next one, this x plus 4, and I'm going to use that negative 4, do I get to use this part here? No, I don't. Do I have to go all the way back up to the top? No, I can use the reduced form, which I used right here, which is going to be 1, negative 4, negative 25, 28, and 0. Okay, so try that one. You don't need me walking you through them all. You agree with that? Easy enough? Okay, so that's how you test factors. If you get a remainder of 0, the answer is yes. If you don't, the answer is no. If you're testing multiple ones on the same polynomial, as soon as you get a yes, you can reduce what you're dividing it into, okay, and keep track of that. All right, any questions at this point?
Just a little one. Let's see. When we were checking x plus 7, you put 0 at the end whenever you brought it down the first one, right?
Mm-hmm. Yeah, because I got it from here.
Oh, okay.
I didn't get it from the remainder. I got it from that. That's a good question. Yeah. Yeah, you don't bring the remainder down. This 0 didn't come from the remainder. It came from that. And that's important because that's your constant term. That's a good question. Anything else? Okay, good deal. All right, so let's look at the directions for the next part. It says, use the factor theorem in the given binomial to completely factor the polynomial function, then give the zeros. All right, we're not going to do number 3 because we're only going to do a couple of these because, again, we don't need to do all these all the time. Let's flip this over. We're going to do number 5. Okay. So it says to use the factor theorem and then completely factor it, and it's given us this binomial. So I'm going to go do my synthetic division. What number goes on the outside? 7, right? Positive 7. So then this is a 2 minus 7 minus 53 and 28. All right. So go ahead and divide that out without me talking you through it. All right, so we got a remainder of 0, which shouldn't surprise us here because they weren't asking us if it was a factor, right? If you're told this is a factor and you don't get 0, what does it tell you? So you did something wrong, so you go back and check yourself. Or maybe you didn't read the question and maybe getting a remainder of 0 or something other than 0 is okay, right? You just check whatever. Something's wrong somewhere. All right, so when I get to here, this tells me that x minus 7 will be times 2x squared plus 7x minus 4. And so I have to get the rest of this factored, so I'm going to factor this. Why can't I just do synthetic division again like I did on the front? Because on the front, you know how I did it again, basically we got it factored? Because we don't have another one. Like, what are you going to pick? I mean, you can check something, but you have an infinite amount of numbers to choose from. That's probably not the smartest way to go, right? We're going to get to a point where we know how to narrow that stuff down. And that's kind of what's coming next. But when you have an infinite number to pick from, don't go that way. In this case, they gave me something. I got it narrowed down. Now I'm just going to factor this, right? So go ahead and get this part factored if you haven't done so already. Remember with your sign, now if you need to do the grouping or whatever you want to call them, you need to do extra steps, that's fine. But on the basic, simpler ones, I'd like you to start trying to maybe avoid that. Remember that what's going on with your signs, my signs are going to be opposite, so I can't plop them down yet since they don't both start with the same thing. But I'm going to need the bigger number to be positive, and since I'm getting a 7 here, and I could put a 2 and a 2, or a 4 and a 1, or a 1 and a 4, I'm pretty sure I'm going to need an 8 somewhere. So if I put a positive 4 here and I multiply this, that'll give me 8, and then I could subtract the 1 off, so a negative 1 and a positive 4. Once you reason through that, before you go on, check yourself real quick, because it doesn't take that long. 2x and 4 is 8, minus 1 would give me the 7, and negative 1 times 4 is negative 4. Because there's a ton of times I see something that's factored wrong, and if you had at the very least multiplied these two numbers, you'd know you don't get that, and then something's wrong, okay? But we all good? So we have it completely factored, so then the next part of those directions it said to completely factor the polynomial and then give the zeros. All right, so since it's zeros, we have to write our answers in what form? Set notation. So what's my smallest one? Negative 4, then what? 1/2, and then 7. Okay, so is this really any different than what we did when we reviewed synthetic division? No, it's actually the exact same thing. The difference is we smacked a theorem name on it. Okay, that's why you get to do it, because it's the factor theorem. So anyway, it's the same thing. That's why we're not doing every single example, because if you can do synthetic division, and you made through that lesson, which was a review anyway, you've done this. You probably just didn't have those words that went along with it, which means we're going to use it for some other things going forward too. All right, so let's look at number 7. We're going to do number 7, because we're not done. There's still a couple I'm going to have you do, because they've got some good factoring in it, and factoring is fun, so we're going to continue to do it. All right, so go ahead and divide this one out. I'm going to work through it up here while you work through it without me talking you through it. So get it divided out, write it down, get it factored, go through all that stuff without watching me, and then we'll see if we agree. So when we get to here on the factoring, some things we know. Since this is positive, that means the signs are the same. Since this is negative, that means they're both negative, and I can go ahead and get my signs in there, right? They've got to multiply and give me 8, so I'm either using a 1 and an 8 or a 2 and a 4. Those are my only options. And I need it to give me 10. Well, with this 3, I don't know how I'm going to get a 1 and an 8 going anywhere, so I'm thinking 2 and 4. If I put the 4 here, that's going to give me 12, but that's a negative 12 minus 2 doesn't give me negative 10. If I put the 2 here, that's going to give me a negative 6 and a negative 4, which would give me that negative 10. Okay. All right, so now that it's all factored, then I need my zeros. What's the smallest one? Negative 5, and then 0, and then 4/3, and then 2. Anybody have any questions? Did I hear, where'd she get that? I heard something back there. We good? Ask me questions if you got them. It's fine. Anybody got one? All right. I want you to work through 8 while I pass out the homework, and then we'll see if we agree on 8 as well. Where'd you get lost in?
I don't know if I got the thing.
No, 12 times 2 is a negative 24. And 3 times 3 is 9, not 3x squared. So I think it looks like you started grouping, but you didn't actually do grouping. Oh, there was already, yeah, so you already have it. Okay. Okay, so when we have this 4x to the 4th, and it's a trinomial, and we got an x squared here, and there's no x here, then we can try to just treat it as a quadratic, right? When your a is not prime, meaning since that's 4, I could have a 4 and a 1, or a 2 and a 2. You have a whole lot more things to process through. So until you get the hang of processing through this and you feel comfortable with it, if a is not prime, you might get lucky in the first thing that you try, but you also might feel like you're going through 1,000 different things and get lost in it. So at that point, maybe grouping would be the best idea until you get the hang of it. But in this one, I do end up with 4x squared and x squared. Right, this is positive, so they're the same. This is negative, so they're both negative. And I get 4x squared minus what? What goes here? 9. And what goes here? 1, right? If 9 goes there, the other one has to be 1 because I got to multiply to give me 9. And when I do this, I've got 9x squared and negative 4x squared. And there's where my negative 13 comes from. But again, if you need do grouping, do grouping. You should be able to factor that either way. You don't have to skip to this step for sure. Can I factor this more? Yes. Okay. Can I factor this part here? Yes. What's this called? Difference of squares, right? We got to be able to recognize them and knock it out quickly. So 2x plus 3 times 2x minus 3. And then this would become x plus 1 and x minus 1. And now I have it completely factored. Okay, we all good? And then I need my zeros. So these two sets right here are going to give me a plus and minus both of those things. So I'm going to have a plus or minus 1, plus or minus 3 halves. and then 3. Okay, we good so far? Good? Any questions at all? All right, make sure you read the directions so you know what you're supposed to be doing there. If you're testing something, or if you're factoring something, or if you're evaluating something, go ahead and get these glued in while you have the time. And remember to have your charged and working devices with you tomorrow.